Dear flight passengers, this is your junior attendant Stella Braunschweig speaking. We have begun to enter the orbit of Mars in order to slow down our shuttle in preparation for landing. Our captain has turned on the fasten seatbelt sign for this reason. Please return to your seats, fasten your seatbelts, and make sure your personal belongings are safely stowed. During the slowing maneuver, Léon Frey will present the last part of our entertainment program. Please note that this is your last opportunity to make purchases in our interplanetary duty-free shop. We accept all credit cards, and focusTerra Space Travel's Platinum card holders can also pay in light years.
Welcome to the third and last part of our entertainment program. Today we'll talk about Mars missions, and more precisely NASA's InSight mission, in which ETH Zürich's Department of Earth Sciences is involved. This mission is currently carrying on lots of measurements on the red planet in order to find out more about its composition. In the last 60 years or so, hundreds of probes have been launched into space from Earth. This overview shows all the space probes that have been sent to other planetary bodies or to interplanetary space. It doesn't show any of the satellites in Earth orbit except the Hubble telescope. Solid lines show past missions and dotted lines show future missions as of the end of 2018. You can see that very few probes have been sent to the outer solar system or beyond. This diagram has been taken from our comic book about space research at ETH Zürich. You can buy the book in our onboard duty-free shop or order it directly from focusTerra if you are watching from home. More information will be provided at the end of the entertainment program. Let's go back to our space probes. In the inner solar system, most probes have flown to our moon, including the famous Apollo missions, which made the moon the first and to date the only celestial body besides Earth on which humans have set foot. Just over 40 missions have already flown to Mars, but only little more than half have been successful. For example, in 2016, the European Space Agency succeeded in bringing an orbiter into orbit around Mars. However, its lander was destroyed during landing. Even though Mars, out of all the terrestrial planets, is the most suited for missions, as we talked about in part 1 of the entertainment program, landing on it is not a walk in the park. One of the last successful landings was achieved by NASA's InSight mission, which we will take a closer look at now. InSight has the goal of exploring the structure of Mars to better understand how it was formed, allowing us to draw conclusions about how all the other terrestrial planets were formed as well. On Earth, plate tectonic processes are constantly changing its surface and erasing geological traces of the past. Mars, on the other hand, does not have these processes. This means that by exploring the red planet, we can gain insights into the beginning of our solar system, which was formed 4.6 billion years ago. InSight is the first Mars mission to explore the planet's interior. All previous missions have taken a closer look at its surface. InSight explores Mars' interior with a variety of instruments. The main instruments on board, SEIS, RISE and the heat flow probe, are meant to treat Mars like a patient, measuring its pulse, reflexes, breathing and temperature. The SEIS experiment is a seismometer. ETH Zürich's Department of Earth Sciences was heavily involved in the development of this instrument. SEIS measures vibrations in the ground caused by Marsquakes and meteorite impacts. Like earthquakes, Marsquakes generate waves on the ground. The Marsquake waves travel through the different layers of Mars' interior, collecting information about the nature and state of each layer. When the waves arrive at the seismometer, they are recorded and researchers can analyze the data to draw conclusions about the structure and composition of Mars' interior. You could say that the waves provide an image of Mars' interior like an ultrasound exam at the doctor's. The heat flow probe hammers itself down several meters into the ground to measure how the temperature changes with depth. This reveals how much heat is flowing out of Mars' interior, allowing us to determine what the heat sources may be. Researchers compare the data with data from Earth to see if our assumption is correct that both planets were formed out of the same material. The third experiment, RISE, consists of two antennas that reflect a signal sent to them from Earth. Researchers compare the signal that is sent with the signal that is reflected back, using the differences to determine how wobbly Mars' rotation is. The wobble shows whether Mars' interior is solid, liquid, or both. To understand this, you can imagine spinning two eggs. A raw egg is liquid inside and wobbles when you spin it, while a boiled egg is solid and spins steadily. This picture shows a comparison between the interiors of the terrestrial planets. Thanks to earthquake waves, we have a relatively detailed idea of the structure of Earth's interior, and we know that our planet has a core made of iron and nickel, which is divided into a solid inner core, seen here in yellow, and a liquid outer core, seen here in orange. The core is surrounded by a rocky mantle, seen here in light brown, which is solid or sometimes viscous. Above the mantle is the rigid crust, seen in dark brown. The outermost layer of our planet is the gaseous atmosphere, seen in blue. Mercury, Venus and Mars have a layered structure too. However, we are still unsure about the exact composition and state of the layers, especially regarding the planet cores, which are colored grey. One of the questions regarding Mars is whether its core is solid or liquid. How is it that we can get to Mars at all? In order to escape the gravity of our own planet, it takes a powerful rocket. The InSight mission used a Atlas V rocket. Like any rocket, it is mainly made up of tanks to hold the huge amounts of fuel that are needed. The tanks are divided into several stages that fire at different times. The first stage fires at takeoff. The rocket lifts off, and as soon as the first stage runs out of fuel, it falls off and the second one fires. The payload, which in case of InSight is the lander, is safely packed and sits right at the top of the rocket. And it is the only part that actually flies to Mars. Now we're ready for liftoff. Let's watch the launch of InSight on the 5th of May in 2018. InSight was the first mission to another planet that was launched from the west coast of the USA, from the Vandenberg Air Force Base in California.
And liftoff of the Atlas V, launching the first interplanetary mission from the west coast, and NASA's InSight, the first outer space robotic explorer to study the interior of Mars.
Of course, we can only follow the rocket's path up to a certain height using a film camera. That's why this animation is used to show how the lander detaches from the rocket and starts its long journey to Mars. InSight was launched when Earth was about to overtake Mars on its path around the Sun. Since the planets keep moving while the probe is on its way, you can't just take a straight aim for Mars. The probe has to fly in kind of an arch to ensure it will actually land on Mars. It's like in ball games when you aim the ball at the point where your teammate is running towards. Once the spacecraft approaches the red planet, it needs to slow down. In case of InSight, this was done in 3 steps. First, the spacecraft entered Mars' atmosphere. Although it's less dense than Earth's atmosphere, it caused friction, thereby releasing heat and also starting to slow down the spacecraft. In this phase, the lander was still inside the transport capsule, protected by a heat shield. Then a parachute was used to further slow down the spacecraft. The parachute was discarded as soon as the transport capsule opened and the lander was released from its protective shell. The lander then extended its legs, and a few meters above the ground, the engines on its underside fired in order to further slow it down and ensure a gentle touchdown. The landing was achieved on the 26th of November 2018 on the Elysium Planitia plain. After landing, the solar panels unfurled to secure the power needed for all the lander's further activities. Then the lander took photographs of its surroundings. Here's the first one. It looks speckled with dirt because the camera was still covered with a protective lens for a while after landing to allow time for the dust to settle. NASA then built a 1:1 scale model of the landing location in the lab to train for every last detail of the instrument deployment. Only a month after landing, The lander used its deployment arm to place the first instrument, the seismometer, on the ground. Here's some actual footage of it. After a few months and several test measurements, a protective shield was placed over the experiment. This shield protects SEIS from fluctuating temperatures and winds, which would otherwise have a strong influence on the measurements. On the 12th of February 2019, the heat flow probe was deployed. Here's an actual photo of it. And what do you do when you arrive in a new place? Of course, you take a selfie and post it on Instagram. Here's one from December 2018, and here's a dusty one from May 2019. The solar panels are still producing power even though they're covered in dust. And in case they should stop, the lander has enough batteries on board to last for the minimum duration of the mission, which is 2 Earth years. But the longer the solar panels can produce power, the better. Because InSight, and especially SEIS, are providing excellent data. And the aim is for the mission to last for as long as possible. Let's have a closer look at the results of the 3 main experiments. The RISE antennas have been taking measurements successfully. However, the amount of data from this experiment is still too small to draw any conclusions about the state of Mars' core. But at least everything is going well there, which isn't the case with the heat flow probe. The probe got into trouble shortly after starting to hammer itself into the ground. It got stuck at an angle just about 10 centimeters deep. In order to see the probe's position, the shield was lifted off. The probe was still sticking out of the ground slightly. The deployment arm pressed on the ground around the probe, but a second hammering attempt failed as well. The probe jumped back out of the ground twice. After more than a year of trying, the deployment arm was used to press directly down onto the probe to push it into the ground. Unfortunately, this didn't work either, and the experiment had to be abandoned. Now let's have a closer look at SEIS, the most successful experiment of this mission. Here's the first Marsquake that SEIS measured on the 6th of April 2019. The vibrations were translated into sounds, so we can not only see but also hear the Marsquakes. You can hear the difference between the vibrations caused by the wind, those caused by the Marsquake, and those caused by the movement of the robotic arm. Since his first Marsquake, SEIS has recorded hundreds more. Most of them were very weak, but some of them reached a magnitude of just over 4 and could be located. By the way, all the recorded Marsquakes are catalogued by the Swiss Seismological Service. Researchers had assumed that most of the vibrations detected would be from meteorite impacts, but not a single such impact has been identified to date. Instead, 2 different types of Marsquakes have been identified. Quakes that are weaker and occur in the upper areas of Mars crust, and quakes that last longer, about 10 to 20 minutes, and occur at greater depths. The researchers compared the data from the Marsquakes with earthquakes and with moonquakes that were recorded during the Apollo missions. They found that the characteristics of the Martian crust, especially its water content, are somewhere between those of the Earth and the Moon. However, we do not know any precise values yet. The deeper quakes also allowed researchers to find out quite a bit about the state of Mars' mantle. There seems to be a zone in the mantle, marked here in white, where certain types of seismic waves, shown in blue, cannot pass through unhindered but are diverted. This suggests that there may be partially molten rock in this zone. These initial results mean that all the previous models regarding the structure of Mars have to be thrown overboard. So we are eager to see what further results the SEIS experiment will deliver. All in all, you can say that InSight has been a great success. As the first mission to explore the interior of Mars, it has already delivered fantastic results, especially SEIS. We can't wait to get new insights from InSight.
Dear flight passengers, once again, here's your junior attendant Stella Braunschweig speaking. The slowing process has gone well, and we will now begin our final descent towards Elysium Planitia. Please bring your seats back into an upright position and close your tray tables. The current weather in Elysium Planitia is a bit cloudy and unusually warm at 20 degrees centigrade. We wish you a pleasant stay or a good continuation of your journey. After landing, please remain seated with your seatbelt fastened until the fasten seatbelt sign above has been switched off. Thank you very much. If you missed the opportunity to buy something in our duty-free shop, you can find our products like the Solar System comic book online, as mentioned previously.